All right, so our next speaker is Nicolas Frankel. He is a developer advocate at Hazelcast, and he is also a self-proclaimed Java geek. Nicolas, I am going to let you take it away and get us started.
Thank you very much. Just so you know, actually, I have my cat, which is sitting on my chair, and it just found out like yesterday that it could do that. And the issue is that sometimes it still doesn't know how to get like down. So if I start shouting or cursing or anything, it's not about you, it's just my cat that decided to do bad stuff. So don't worry, just be nice with me. I am Nicolas Frankel. For like 15 years, I've been working like as a Java developer or team lead or architect or solution architect. 1 year and a half ago, I decided to become a developer advocate, to completely change my career path. And then I started getting curious about Kubernetes because it seemed to be very interesting. And the most important fact is, probably like you, I'm stuck at home right now. So I decided, hey, let's try to meet people even virtually. Because even as a geek, I need some social relationships sometimes. I work for a company called Hazelcast, and I'm a bit disappointed that it was not announced in the previous talk, because I have like two products. The first one is called IMDG. It's an in-memory data store, and basically our main use case is caching. We also have another product which does in-memory streaming. But this talk is about neither of them. So this talk is about how you can create an operator on Kubernetes. And Kubernetes, I assume everybody knows now, is familiar with it, and basically is just a platform which allows you to deploy your containers, and you have like a lot of stuff that can be automated, like self-healing or scaling and this kind of thing. And Kubernetes architecture, from a very high overview, is you have these API server. I will talk a bit about it because that's the most important stuff for us to interact with today. You have the storage, where the state of the cluster is in. Then you have all your worker nodes with your kubelets, and then you finally have your container runtimes. And so basically your runtime talks to, like, is handled by a kubelet. But again, it's all about the API server. And I don't know about your experience with Kubernetes, but basically there is this API server again, which is the facade. So you don't store your configuration directly into etcd, but you send REST requests, and you receive responses with JSON payload, and that's how you interact with it. And for example, if you use kubectl, that's exactly what you're doing. So if you, I don't know, get the pods, for example, so I will, is Minikube launched, and if I just copy paste this stuff because I don't want to do anything bad. So I will assume, yes, it's big enough. And you can see here, just getting pods is just making a get request to localhost on a certain port with a certain URL and some parameters. And then I get an HTTP status 200, and you can also increase the debug level. And here, for example, which is truncated because it's super big. So interacting with Kubernetes, even through kubectl, is just So now is the question of a controller. And I struck out the title. I struck out operators. I will just talk first about controllers. And controllers are just control loop that basically, one, watch the state of your cluster, then check what state is required, and try to move the state of the cluster to the desired state. That's basically what a controller does. And if you know about Kubernetes already, you know about, for example, the deployment controller. Deployment controller you say, hey, I want, like, let's say, 3 replicas of this container, and then it will create 3 pods of this container, and you remove 1 pod explicitly, then Kubernetes will watch it, will say, oh, there is 1 pod less, so there are only 2 pods. I need 3 pods, and it will a controller. This is a control loop. This is a very simple control loop. Of course, when you don't know about Kubernetes, I mean, I myself was like, I was like really amazed by this self-healing behavior, but it's just like just watching the status and just trying to move the existing status to the wanted status. And now the second question is, where are those controllers located? Well, obviously, the deployment controller runs in the control plane, where the place where you should normally don't access. But actually, if you create your own controller, you can run it anywhere, as long, again, as you are able to talk to the API server. So you can, of course, run it from inside the cluster, and then you can benefit from self-healing, from limiting of resources, from the scaling, from everything. But nothing prevents you from running it from outside your cluster. So you just have the control loop, and you say, hey, what's the state of whatever? And you get the state, and you say, oh, I want it to be something else. And then you send the command to change it. And that's very easy. Now, as I mentioned, I trust the operator and the controller, because like a controller and an operator are very similar. Basically, an operator is just a specialized controller. An operator operates on like specific resources. Controller can control anything, but operator will control something called like a custom resource. And you might know that it's quite easy to create a new, to change, to update, to add the model, to enrich the model of Kubernetes by adding a new custom resource definition. For example, this is how we can define a custom resource definition of a Hazel costs node. So we can create a stuff called Hazel costs, and then you can have a plural, which is called Hazel costs. And to your Kubernetes, afterward, you can say, hey, kubectl get Hazel costs, because now it has become a new resource in your cluster, and it can list the Hazel cost, whatever that is, in your cluster. Of course, here we don't know what is a Hazel cost, how to create a new one, but we define the model. Basically, what you can think about it like we declared a new table. Of course, it's not a real table, it's very dynamic, but this is how you can see it. So basically, an operator, as I mentioned, is just a controller that manages a CRD. And if you know how to develop a controller, you know how to develop an operator. So let's focus on how to develop an What do we need? We need like talk to the API server, which basically is REST-based HTTP and JSON. That means that we can create a controller by using just a shell, just like a simple bash with curl. And then we can use JQ to get the JSON and to interpret it. It's like very, very simple. But a lot of people are creating their operators in Go, and there must be some reason for that. Well, the thing is, like, Kubernetes was first written in Java, but everything has been migrated to Go some years ago already. And so Go became the most used language, sorry, in the Kubernetes ecosystem. Also, a lot of people who care about Kubernetes are actually ops, not DevOps, because I mean, DevOps can mean a lot of different stuff to different people. but they are ops people, and they need to care about the application that they run. And in general, they are not programmers. So they need a very simple language for them. And Go is made to be simple. And I push back on that because I'm a developer, and this is the stuff that I need to write when I need to write Go code. So basically, I call this getFoo method, but it might return an error. And there is no exception in Go. I mean, there was like 1 or 2 years ago, there was this like community asking, hey, can we have exception? And another part of the community said, no, we don't want exception. So in Go, you can have a multiple return value, and there is always this error. And then you must check every time that is error is not null. If error is null, then you have an error, obviously. If error is not null, you can continue. And when I started learning Java, like perhaps 20 years ago, nearly 20 years ago, I was coming from the university, so I learned C and C++. It was exactly this kind of code that I hated. And Java made the change, let's say it's made able to like have the business, the normal flow code in one block and the exception handling code in another block. I know a lot of people now push back on the exception mechanism, saying it's hard to reason about, but to read the code is actually much easier, because I have a hard time reading that kind of code. And yeah, if I don't want to bitch about Go, but for me, it's not for me. And of course, we can make jokes like there must be like this keyboard with this key and this pattern always, because then it will make your life easier. So the question is also, but hey, we are a Java shop, we are a Python shop, why not use another language? But because learning is a new language is not that easy. Everybody can learn Go. It's easy to say to learn Go is just learning the syntax. I mean, I tried Go. It's, as I mentioned, not my favorite language, but the syntax is easy. Now, again, I remember when I was starting writing Java, I saw a lot of Java code at that time that looked like C code, because people were migrating. They used Java in a C way. So it's not only about learning the syntax, it's writing the code in the idiomatic Go way, which it takes a bit time. And then you have to know the ecosystem, which is not only the libraries, so you have to know which libraries to use, but also the tooling. For example, how do you debug Go code? How you do I know how to debug a remote Java application, but I don't know how to do that in Go, and I need to learn it, and it might not be as straightforward. And so my point is, if your team already use language X, just use it. And again, there is no reason why you shouldn't write your operator in X. But I'm a Java developer, and so X for me is Java, and so I want to write an operator in Java. But this is just an example. You can do it in Python, in Ruby, in Bash, in whatever. And now is time for a little demo, because otherwise it might get. So I've created a stupid Java. Like here, I have this plugin. I will talk about it a bit later. I have two dependencies. The first one is just to log, because I need logging. I need to show you that what I want to do works. And the other is about this Java API for Kubernetes. There are a lot of different libraries, actually. You can go on the official Kubernetes GitHub repository, and you can get the library for your language. This library is actually just a simple generated client from Swagger. So it's very, very close. I mean, and I will show you later if I have time that it's too close for my taste to the REST API. So it's just like a simple binding in your language. And now I have the basics. So using this API, I can like create a client and where I will actually list all pods for all namespaces. And as I mentioned, I don't like this API because here, for example, I have to call this with all null values, but I'm required by it because it expects that many parameters, even if I don't need anything. So if I just call the list pods here, and now demo gods, please be with me. Yes, it works. Those are all pods that are deployed in every namespaces. Like if I do the same here, and I say get pods, it's all namespaces. I never remember. Yes, and you can see that this is the same. Of course, here I have the status and everything, the age, but because I own this is not a controller yet because there is no control loop, but actually I'm already the API server, so it's already something, and I don't need much. I just need like a Java project and this API. Python, you would have the same, or Ruby, you would have the same, or whatever, you would have the same. So one library, your language, and you're good to start working with Kubernetes. Okay, this is not that fun because right now my program runs outside and I would like to benefit from Kubernetes platform, as I mentioned, scaling, self-healing, whatever. So I want to deploy it from inside. So I want to create a container out of this program, and this is this plugin. I'm super lazy. If you are using Java, for example, then don't create a Docker file. Use this plugin, and this plugin knows how to layer your Docker, well, not your, to create the right image for Java. And the good thing is that it will create multiple layers, so libraries will be a bit deeper. So, and libraries, they don't change that much. And basically, if you change your code, there is a layer above. So if you change your code, then the image will be created faster because it will only change the above layer. So that's a good stuff. You can, of course, by default, it will send it to your Docker Hub account, but here I want it to be done on my local Docker daemon, and so I use Docker build. And because I don't want to do that every time, I already did that. So here I have the Docker images of all my version, and I need to grep only for this one called G. So here I already prepared everything, and as you can see, I did that stuff a long time ago, so I'm very good because I did that even before Kubernetes existed. Now, it's just fun because if you are using this Git plugin, by default, this Git plugin doesn't use any timestamp. So basically, what you're creating is like 50 years ago, but it's not required. So this is this one, this 1.0. So now I want to deploy it inside my cluster. I have this deployment file. So I create the namespace because I'm a good citizen. I always try to be inside a namespace. This namespace is called JVM operator. And I have this like simple pod, and this image build policy means don't get it from Docker Hub, get it from the local Docker daemon, which, as I mentioned, is already done by this compile. So normally I should only do mvn compile. It will create, of course, by application, it will create the Docker image, and now I can use it. And now I want to deploy it. So I have aliased my and I have deploy. So I will apply this file deploy.yaml. And now I've created something, and I'm super happy because now my controller, oh, but there is an error. I have an error. So why do I have an error? So let's check the logs. And that's the first problem that you handle when you try to create your own a pod that interacts with Kubernetes is basically when I was working outside of the cluster, this client here, the default client, was smart enough to get my credentials so I don't remember, it's in my profile / Kubernetes, I think. But now I'm inside the cluster, so the credentials are not there anymore. And it's a good thing because actually you don't want everybody or any pod to access your cluster. You want it to be as secure as possible. So I need to create some authorization. So I need to remove that. Okay, delete pod custom operator. And I will just use Git because I'm super lazy. And I will check out this stuff. And I create this authorization. And this is the...
Nicolas, I believe a lot of us are having trouble hearing you. So maybe if you can just, for the last part of your presentation, of your talk, just turn off the camera and see if it works a little bit better.
Okay, sure.
Okay. Sorry to interrupt. Thank you.
Oh, no, that's fine. I know that sometimes I have issues with my internet connection, even though it's like a normal cabled one, but okay. Delete the...
Nicolas, I think we lost you.
Finally get the logs. I'm still here. I'm here.
I heard get the logs.
Yeah, get the logs. Get the logs is good. That's good. So let's get the logs. And here you can see that I have actually what's happening inside my cluster. So I have added all that stuff. Now, if I don't know, I deploy a new deployment, for example, the logs have been modified. So here we can see what happened. And get deployments, yes. Let's see. So here you see that it's still being changed all over. And now we can remove them because it was just for fun. Delete deployment HZ. And we can see it has been deleted. So now we are reacting to changes. We have subscribed to events. Now we get code that is executed when something changes, which is pretty cool, in my opinion. Still, we are still just watching logs, which is not that interesting. So the next step is to finally do some loop. And if you know about, there is something called a sidecar pattern. So basically, instead of deploying your container and you put a lot of stuff into your container, what you will be doing separation of concern, and you will have the main container, and you will create another container which does something additional. And what you want is when you deploy the main container, you want to deploy this other container automatically. And that sounds a lot like a controller, like a loop that watches that when a controller is deployed, then you get to do something. And so I will get here. And because I still have 10 minutes, right?
So you have technically 1 minute left for your presentation, but we have 10 minutes for questions, so you can eat up into that time. Okay, so I will take, I will be a bit like faster. No problem.
So now I'm having this, so I change it to have this like event handler, and now my code, like starting code looks a bit like that. So as you can see, I'm using this not so great Swagger API binding. So null, null, null. Here I need to pass something different. But here I have this handler. So I have 3 main methods, on add, on delete, on update. And now, of course, I need to add additional verbs because my controller now needs to do something. So it needs to create and delete. And I will apply.
I think we lost you again. Hello? Nicolas?
I'm still talking. So if at any point you hear something, that's fine. So now I've created something interesting. I've created my custom operator. And because this is a pod, it got deployed into Kubernetes. And this new pod that I never asked explicitly to be deployed was deployed. This is my sidecar. I try to be smart. And actually what I did is on delete, I say, if it already has a sidecar, then delete it. So let's see how it works. So I want to delete this pod, this custom operator. But it was not deleted because I'm sewing the branch on which I was. So trying to delete your own sidecar is not a great idea. What you should do instead is to use this ownership. So basically you have this Kubernetes at this idea of ownership. And basically this ownership allows you to say, hey, instead of deleting this pod, I will say that this pod is owned by me. So when I delete me, then Kubernetes will take care of deleting it. I won't show it, but it works like the same way because I don't have that much time. And now what I want to show you is how better you can use another API. So this API is called Fabric 8, and it's not the official Swagger client, but it makes your code much, much nicer. Basically, this is, and if you have been doing YAML, this is exactly, it looks like YAML. Of course, I use the formatting, but this is a Fluent API and it looks a lot of like YAML. So API version v1, kind pod, and you have the name, you have the namespace, this kind of stuff. So everything here is the same. It still works in exactly the same way. So I can apply f this deploy.yaml, and I can show you. And I missed something. So I'm not using, I'm using the API, but not the watch API of Fabric 8. So I need to upgrade it because otherwise it doesn't work. Delete pod custom operator. So nothing. And now I can apply f deploy YAML, get pods. Yes, and I have everything. And I can get the logs and, sorry, logs of that. So you can see my custom operator is having some fun. It has started, it has created this Hazelcast custom operator. Now I still have one issue. Like if I show you the images size, this is version 1.7 or 1.8, I think, and it's 200 megs. 200 megs to just create a simple and stupid control loop, which is a lot. So the next step that I won't have time to show you is to use something called graalvm, and graalvm has something basic, like to be very, very fast, to create a native executable. So you can create a native executable out of any jar or war or CORS file in Java. And with it, I can have something that is as small as grep gvm. And you can see I have something that is only 40 megs, which is much better. So now if I do this, I get here, I check out master, and I will just remove the last, not this one. I will delete my custom operator. Get pods, it gets deployed very, no, what happens? That's logs, let's check what happened. This is the demo gods are not with me. What did I do? I did something bad. I didn't get the right one. Let's try again. Delete pods custom operator. I kid you not, I tried it this afternoon. Everything went perfectly well. And now, get pods. Okay, let's forget about it. It should work. And now, this is the end. So in this very fast presentation, I try to show you what are controllers, the difference between a controller and an operator. You don't need to know Go, you just use your normal stack. And if you are a Java developer like me, you can use Java. And by using graalvm, normally you should have very small images. And if you like this presentation, you can read my weekly blog. You can follow me on Twitter. And more importantly, you can get the code out of the repo and just try to do that by yourself and not have the demo code against you. And I will switch on my video again because it will be much easier for you to ask me questions. So now my cat is gone. I feel much better.
Okay, we have one question to start with. It says, should we create a controller for our software, and what would be the ROI?
The question is good, actually. The answer is it depends. It depends if your software basically is hard to configure. If you need to do always repeatedly the same stuff, then creating a controller is always good. Like if you check at all the controllers, they are basically a way to avoid to add an additional config file inside your deployment. So it just allows you to be nicer. So if you have a service provider, a software provider, just like Hazelcast, it's a good idea because it allows your customers to be easy.
Thank you very much.